Hi, King. Good afternoon for me. Good morning to you, and happy Saturday to you.
Yeah. Hey, Reed. Thanks for
Hello
having me
from
back
the.
on.
Absolutely, yeah. So, hello to the future. I have to
Yeah,
say that every time I do
exactly.
anything from Oceania.
Yep. It's a lovely Saturday morning here in Sunshine Coast.
This is the third time I've had you back on.
Third time, I think. I think we did some calculation group stuff. Then we looked at the report design competition,
Yep,
field parameters report design competition I won. And then I think this
that's
is
right.
number three.
Yeah. Because you had one where, if I remember, there was a button for like a randomizer. It was like a dice or a die where you click it
Yeah.
and it would I think put the legend. It would reconfigure legends and X and Y axes and all this on the visuals, right? Oh,
Yeah. Basically rotated the available fields through um, through axes and legends.
yeah, that was a good one. I think that was the tipping point, if I remember, on why yours one is like the random button was a cool extra bonus on that. Yeah.
Yeah, it was a fun report. If there are a lot of fun field parameters, I really like them.
Oh yeah, they're great. I actually have a video upcoming soon that I'm gonna do, but the uh my a client has a request where they need categorical attribute columns in the field parameter to change when they edit them in another system. So I'm going to do some clever uses of the is private feature in tabular editor to actually obfuscate the table, but then use the related function to add them as calc columns onto the field parameter table. But they change the label upstream of whatever, because it's like
Uh,
25 measures, and they would occasionally rebrand them or relabel them at a parent level, and that will essentially do that. I will also at some point, I think, figure out if I can use Fab Cat Tools or something else in a notebook to generate a Tyndall script to actually rename the display name of the measures, because the client also needs to do that dynamically. But I'm continuously finding new ways to try to dynamically update the hard coded field parameter tables when I can. So
yeah.
they're always fun to play with.
Yeah, it's funny. I think that it's becoming harder to find really good calculation group use cases because they are quite flexible field parameters. There's a lot you can do. There's still plenty of good stuff you can do with calculation groups, but performance is always tricky. I think field parameters are so performant that it's a lot.
It's still
They're always
yeah.
my go-to.
I think it's I'll still like the remaining things left that I use calc groups for is probably um it's the scaling, because I'll usually have measures that trigger based off of the calc group, where it can like trigger by per visual or per measure, and relationship paths. So like
Yeah, it's a
change
good
the
one.
page for from order date to ship date to delivery date. You don't have to have separate measures. You just have that. Those are the
Mm,
two ones
yeah,
left where uh,
yeah.
parameters couldn't do that without a ton of measures. You would have to have
Mm,
extra. But yeah, I
yeah,
would agree
yeah,
that the Venn diagram is like overlapping, where there's more and more field parameter
yeah.
functions to do that. There's still some annoying limitations that, like, you can't reference the field parameter. They
Mm,
they break if you composite model a core model that has field parameters in it. Like there's some annoying small things, but yeah, overall they're
yeah,
still to my
yeah.
day to this day like the one of the coolest, most useful report design things that took so much hacky modeling out of the model.
Yeah,
they and it,
yeah.
it it made like a 5-hour project 5 minutes.
Agree. Such an easy way to get a good report happening and something that it's like got some wow factor and will impress people.
So I know we're going to be talking about some timesheet stuff today, but before we get into the topic of that, for the people tuning in now or later, do you want to do a brief introduction, who you are, what you've been up to, and then we'll segue into the topic of the day.
Yeah, I mean, I have got a slide
Oh yeah.
on me if I want to, if I share my screen, maybe that'll help me remember about myself. Um, so yeah, um, I guess I'm wearing a few hats at the moment. I've done all sorts of things. I've been in business, in consulting firms, I'm currently a head of analytics, but I'm also working as a fabric architect and analytics practice lead. I kind of jump around a bit. Been doing Power BI and DAX for a long time. Been deep in fabric since it came out. Worked across a lot of different industries, some of the biggest businesses in Australia. Cost is probably one of my kind of passion areas. I really am into finding low cost ways of doing stuff. So I do a lot of looking at how to automatically pause and resume capacities and what tools you can use to do things cheaply. Obviously, I've done some user group talks and YouTube streams with yourself. Known for calculation groups, probably because that was the new feature when I had a bit of free time, and I presented and wrote on that a bit. But funnily enough, I do have other skills than that, so can talk shop on UX design. I do a lot of solution architecture. I'm quite an admin and governance nerd. I love those kind of whole business designs and workspace structure and all of that kind of stuff. And yeah, do a lot of leadership roles, both in business and analytics. Also enjoy mentoring other consultants and leading teams technically. So that's pretty much it.
And do you still go by because your Twitter used to be 10 fingers, right?
Yeah, I think my
Do you
blog
still use that
sort of
handle
like
at all,
a really kind of. It's sort of just like a really old an old nickname or something that's hung around for a long time. I feel like maybe I should try and be a bit more something more professional, but no, it's good fun. I mean, yeah, I still got that in my blog and Twitter. It's to do with like playing music. I like to play a bit of guitar on the side, and it was like an old nickname I had, so that's where that comes from. But yeah, it's still there on Twitter, although I find myself these days not on Twitter a lot. I'm much more on LinkedIn, and my blog is unfortunately severely neglected. I really need to give it some love. I've just been super busy.
Yeah, I feel like it's always good to have a little bit of playfulness in a business personality, right? I mean, you look at like Simon Wheatley or others, like they're super goofy, but also like incredibly smart people and very successful. So I think you can definitely do a bit of the dance between the two worlds and still have things work out.
Yeah, 100%. I agree. It's not good to take yourself too seriously.
Exactly. All right. So I think like also thinking of the topic of the day today, like related to like data modeling, essentially like time tracking data, people, timesheets. Where would you like to start on that?
Yeah, I've got these slides that I put together. So there's a bit of that. There's also, we'll look at some DAX and some reports, but I'll basically look at a little bit of the why in the next slide, which is, why is this important? What's it all about? Then spend a bit of time on some of the modeling considerations. I've got some tips for this kind of implementation. And then we'll look at some of the more complex DAX, some use cases, and then I've got a couple of reports to show. So a bit of everything, sort of a little bit end-to-end thinking about it. So I mean, I can jump straight in if we want to.
Yeah, let's do that. Get our hands dirty.
All right. So a little bit about the why. I mean, it might seem obvious, but I think it's important to talk about, I guess, wages in general. I mean, there's a lot of different types of time tracking that happens in business, but wages itself are probably most businesses' biggest expense. You could find some exceptions to that, I'm sure, but in general, the biggest outgoing expense for a lot of businesses is wages. So it's kind of low-hanging fruit, really, in terms of finding things that you can contribute value to a business with, because it has a direct impact on their bottom line. Some businesses more than others. So if you have casual staff where you're tracking hours of any kind of hours tracking business, so law firms, consulting firms, hospitality, all of these kind of businesses that track with hours, it's a real good use case, right? Because there's still timesheets with salary type businesses, and it's still important to audit them and track them and report on them. But when you have people charging by the hour, it becomes even more important. So rosters versus timesheets. Rosters are great too because they're like the forecast of your biggest business cost. They're saying this is what we think is going to happen in the future. This is the schedule or the roster. So while timesheets are great for auditing and review, rosters are amazing for forecasting what's your wage percentage going to be, what's the cost going to be in the future. And I think I said, yeah, it's just a very easy, not easy, but it's a go-to for quickly finding something that you can deliver some value to a business. You say, here's one of your biggest costs. Let's dig into it and find out what we can do. I grabbed a couple of stats from the internet. I said, 20 to 30% is pretty common for a business, but I found some web results that said, 40% for labor-intensive businesses like theme parks or hospitality, even up to 60% for some transportation businesses. And then there was some information as well that time theft can be around 5% of your gross payroll costs, and that most business struggle with it. So saying that most business struggle with timesheet accuracy. And if you're a large business, 5% might sound small, but it's significant if you're a large business. So I guess the point of this slide is just to say this is important for so many businesses. That's why it's important to dig into it and know about it, because no matter what business you're working for, there's bound to be some kind of use case for it.
My favorite, just your whole thing is like, 5% can be big for a large company. It's like, it reminds me of that famous story of, it was either American or United Airlines or something like that. They took 2 olives out of every salad served, and it saved them $2 million a year. Yeah, like there are certain things that at scale, like it's like you're literally pinching pennies, but like when you roll that out to like 20 million things served or something, it does go into a large chunk of cash that you can potentially save. So yeah.
Absolutely. That's the point. It's like your biggest cost for a business, biggest outgoing cost. So even if you can audit some timesheets and find a couple of things before it goes to payroll, it's wins, right?
Yep, 100%.
Cool. All right. So we'll dig into some modeling. There's a lot to cover here, so I think I've got a few slides on it because it's a big depends, to steal from the Italians. It's definitely not this is the way you should do it. So when we think about modeling, the first thing we want to do is define the grain of our fact tables. It's interesting with timesheets because your source systems often store timesheets as one row per timesheet. It's this timesheet, it starts here and ends here. It's timesheet, start time, finish time, and date. When we're thinking about modeling it, one of the main things to think about is whether you need to report by time or date. If you just need to look at numbers of things by date, like this is the total cost of my timesheets per date, this is the total amount of hours per date, that kind of stuff, then you probably don't need it at time grain. But some of the examples we'll look at is like, what if you need to look at a day and see how those timesheets overlap and how they are across time? Then you might want to put your fact table at time grain, but it's not a just yes, you should do that. It can make some DAX easier, right? If you have things set up like the tables that I've got on the screen here, where you have, the first one is like every minute of every date with every employee, and then the status of their timesheet. I've got lots of dates here, but it should be like one date, but basically saying a snapshot for every single minute of the day, and then whether the timesheet was active.
If you can, I'm thinking just to double check. I don't know if the screen's frozen, so should it still be on timesheets or rosters, or should there be a different screen?
It's on. It should show some tables on the screen.
Okay. So I think we might have to do the screen. The screen share is only showing Moonda. Okay, yes, you finally mentioned something where I realized, something different should be on the screen. There we go. Now we're here. Okay, because everything else was conceptual. It didn't quite click that I needed to see something, and now we're there. We go. All right, we're good.
Cool. All right.
Golden.
Okay. Sorry. So yeah, this is what I was talking about. A big depends, and then I was looking at these tables where you could, to make DAX easy, say that for every employee I want to see the status of their timesheet for every minute of the day for every day. And then, it does make certain things easy, right? Because you can just, because if you're reporting by time, your fact tables at time grand basically make some DAX easy. You could, but that's a lot of data, and we'll see on the next page. I'll do some examples. And then, the second example is maybe defining it at 15 minutes, because a lot of timesheets aren't down to minute level detail. They might be always rounded to 15 minutes. So defining it by every day, a 15-minute snapshot for every employee for every timesheet. But if I click to the next slide, which looks like my next button. Oh, my browser's frozen. Always happens on a live stream, right? Let me see if I can fix it.
No worries.
I might have to reopen it. Has that done it? There we go. Yeah. Seems like we're back in action, but am I still sharing? All good?
Yeah, I still see it. Yep.
Okay, good. So what I was saying, it's not always practical to do this, right? To say, let's just snapshot everything for every minute of the day, for every timesheet to make DAX easy. Because a couple of examples is, even if you have like a small company with 500 employees and you have 5 years, very small amount of timesheet data, that's still like a 1.3 billion row fact table. Even at 15-minute grain with a small amount of employees and a modest history, that's like 87 million rows. And then if you take a bigger business that has like 10,000 employees, you could have like 350 billion rows for a single year. So it's not always practical. So before we decide how to model it, we need to ask a lot of questions. We need to know, what is the detail that it's recorded at? What is the detail that we need to report on? How much history do we need to store? How many timesheets do we have per day? How many employees do we have? What sort of metrics are important? Are we going to be reporting by time? Are we going to be reporting by date? There's hybrid approaches you could do too. You could store history at like a date level, and then more recent timesheets at a higher level detail if your reporting is mostly when you're looking at time, if it's more in recent times, if you don't have to compare like a 2 p.m. shift to a 5:30 shift currently to previous years. There's all of these considerations. It's not, there's a lot of thinking that needs to go in before you decide how to model this, is what I'm trying to say. So when you have the table at timesheet grain, which means for every day, you have every timesheet for every employee. That's basically the level of detail. This makes counting timesheets and staff easy, right? You can just do like a count row of timesheets, and that's basically your number of timesheets, number of staff. If you want to report it by months and days, it's simple, right? Anything reported by date is easy. Your calculations are over a smaller table because you not have that high level of detail. And when you go to that time grain, when you go to the higher level of detail, you start needing the distinct counts over larger tables. So there's a consideration there. There's also a cost element to it. So firstly, most systems, like I said, store timesheets at a timesheet grain, one timesheet per date per employee. So changing to a time-based grain for that table means that you're going to have to transform it, and you're going to end up with larger tables. So it's not just a cross join too, where you just, say cross join all these timesheets by every minute of the day, because you got other metrics in there like duration and cost. So there's thought like, how do I need to split out duration, cost? There's complexity there in planning how you're going to increase the level of detail with the timesheets that already are at a certain level of detail. And you're saying, now I want to split it out over every minute of the day or 15-minute increments. There's a lot of thinking there. And it adds up to, a significant amount of overhead and processing, which equals cost. We might not have Fabric and all the tools to ingest this and transform it. We might be just using Power Query and directly connecting to a source system and pulling timesheets directly in. Power Query is probably not going to be able to handle a lot of timesheets, and well, it might be, but depending on the data. But doing that kind of heavy ingestion and processing in Power Query might blow out your refresh times and end up with endless spinning wheels and that kind of stuff. So I guess what I'm saying is, yes, it depends, but there are some good benefits to keeping it at just the timesheet level, Graham. There are some benefits to increasing the level of detail, some simpler DAX potentially, but there's also some benefits to keeping it at timesheet grain. Breaks is another one that you need to consider, depending on your timesheet data. If you have sort of hourly based or very detailed time tracking based data, breaks can trip you up, because often with shift based kind of data, you have multiple breaks per timesheet. So if you usually need to store that in a separate fact table, because you have one row per timesheet. If you tried to list breaks at that level, you'd end up with duplicate lines. So you need to have a breaks fact table as well. I don't know how well I explained that, Reid, but hopefully the point got across. But yeah, it's
even with a lot of repeating values, like 350 billion rows is definitely premium capacity at that point. I mean, assuming if you have 10,000 employees, you're going to be used in some capacities. But
yes.
yeah, I guess
good point.
Mm.
I think that's what I'm getting at with here is I said at the start, like, I'm really passionate about low cost solutions, and I guess I put a lot of this validation in here because I'm going to show you some examples with the timesheet grain of one date per timesheet per employee, and the DAX is a bit complicated, and I'm thinking people might say, well, why don't you just simplify the modeling side to make the DAX easier? And I guess this is the validation as to why. Is if you want a low cost solution, as long as the DAX is performant, keeping it at that higher level of details makes certain calculations easier and is lower cost. It's less processing and less large tables.
True.
All right. So a little comparison here. Basically, if you don't mind getting your hands dirty with some DAX, then it can be lightweight, fast, and cost efficient if you keep it at that timesheet and date grain. So a couple of this is biased towards what I'm going to show, the timesheet and date grain, but I'm basically saying, look, you're going to have smaller table size. Your ingestion complexity is less. That could equal less cost. Date-based calculations are much easier, summing things across dates. You can keep a larger history. You can deal with a larger number of employees. You could probably deal with things in Power Query only if you need to. The only place where it can be better to have the higher level of detail is if you want simpler time-based calculations. And I think I put in the link, there's a good SQL BI article on events with durations, I think it's called. And they show some examples, but they're examples for both with snapshots and for events with start and end dates. But it's a little bit different. You'll see when we get down to the time level, there's some additional considerations, which is sort of what I want to add here. It's not, I'm not just copying SQL BI. There's some other considerations around time-based stuff. So that's what we're looking at today. If you have your timesheets or rosters at one row per timesheet per employee per day.
Yep. So 365 rows per person per year. Yep.
Yep. 365 rows per person per year, which can still be large, right? If you,
it's essentially yeah. I mean, it's aggregated to the day level. Basically, it's like
exactly.
Somebody worked. Yeah. I feel like that's the vast majority of the stuff that I see getting pulled in for any reporting. Is you want to see per day, where's the allocations between whatever categories of time by department, division, management, etc.
Yeah. So I guess the use case that we'll look at next is when you need to do detailed time tracking. So you want to look at a single day and you want to see across that day what your wage costs were per 15 minutes per minute, versus revenue or something like that. So good for industries like hospitality, where you have, you might have a large venue or something that has lots of staff, and you can start and finish those staff at different times, and you need to know, how are you tracking throughout a day? How many people do you have? What's the cost of those timesheets over time? Can be good for things like manufacturing industries and things as well. Anything with like shift work, where you need to have like a high level of time precision on when did people start, when did they finish, how many people do I have on the floor, that kind of stuff.
True.
Which is why I say when you need to do time-based calculations, the higher level of detail may make things easier, but there's all those considerations. So I'm going to look at how do we do those time-based calculations where we need to look at like every 15 minutes, how many people do we have? But how do we do it when we have everything at a timesheet date grain? So just something to keep in mind when we start to look at the DAX is, this is a timesheet fact table with date and time connected. So normally you'll have a start date and an end date for a timesheet. And in this case, the timetable filters by the start date. So it's important to keep in mind. If you have an axis with times on it, and it says 6 o'clock, that's going to filter all the timesheets that start at 6 o'clock. So it's just good to keep that in mind, because when we start talking about the DAX and why it's done a certain way, we need to keep that in mind, that the time on the axis is filtering things by start time.
True.
Okay. Before we dig into the DAX, I've got a few tips. So one is to define the start and end of a day, because if you have businesses that run shifts, they can run 24 hours a day, they can run different times. So you might have shifts that end after midnight, you might have night shifts and day shifts, all sorts of things. So the day start and end is defined by business hours, not clock hours. And then part of that is you might want to offset your dates based on that day start and end. So say if you have a business that has runs from say 11 o'clock in the morning till 11 a.m. in the morning till 2 a.m., it's crossing two dates, right? But often when you do the reporting, they won't want to see that the cost of their wages fell on two different dates. They want to see, for this day, my business ran from 11 a.m. till 2 a.m. I want to see the cost of that for that date.
So
you
want to see it by those. It's the custom date windows essentially that you have.
Exactly. Yes. So you need to think about this.
Well, one thing I'm just curious on is actually, coincidentally enough, the company was in Australia. It was a mining company, but they had shifts for their construction, like equipment and all that, on specifically on like downtime, uptime, blah blah blah. So timesheets, but for machines, not people. The interesting thing though was their shifts were they weren't non-overlapping. They were overlapping. So that became a little trickier. I think I had a custom table connected to the calendar table, due to the fact that like you couldn't just have a column with like shift 1, 2, 3. They would have those overs, because I think there was an hour overlap between each. So it ended up becoming a special table to appropriately be able to like chart on a graph these time periods and the time with that. But not overlapping custom shifts was an interesting problem to tackle. I would curious, like, I guess if you've had to go through similar.
Overlapping custom shifts.
Or just overlapping shifts. You because specifically it's because they need a transfer time. So to like in terms of moving shifts, so they usually had about an hour of overlap per each.
I don't know if I've come across that specific use case, but I think it's so interesting that there is so many use cases for this time-based kind of stuff. And I feel like all of our examples out there, when you go look at DAX on the internet and stuff, there's so much date-based calculations and stuff. And it's quite tricky when you start working with time, I think. It requires a lot more thought. So no, I haven't come across that, but it sounds interesting.
It was a fun
Yeah. So
problem.
look, yeah, I love those kind of things. I love it. I love a good combination of modeling and DAX. That's my happy place. So yeah, look, you can add a simple column for this use case, like I said, where you can just say, if it's this time, offset the date basically. You can have your normal date, and then you can have a business date that offsets based on the time, so that when you filter on that date, you can get a window that goes from say 11 a.m. till 2 a.m. Another thing that I found handy is to take your times, like your start time and end time, and convert them to a number. It just makes understanding what's happening easier when you look at a number rather than a time, I find. It allows you to do a better custom sort order as well. So like if you want to run your times from 11 a.m. till 2 a.m., you try and sort that by time, your axes are going to sort all funny, right? Because 2 a.m. actually comes before 11 a.m. and it's the next day and all of that kind of stuff. Even with your date offset, the times won't sort correctly from 11 a.m. till 2 a.m. But if you define a custom number for your times, like start it at, what would you start it at? 2:01, say, as 0, and then 1:59 as 14:40, it's 1440 minutes in the day, something like that. Then you get that custom sort order. Everything kind of works. You've got just a nice sequential minute number from the start of your business day to the end of your business day. It makes things easier.
Yep.
And I think I've got an example there. Like, think about if you want to calculate the duration between 11 p.m. and 2 a.m. Is that 3 hours? Is it 21 hours? Just makes additions and subtractions easier, because if in that use case, 11 p.m. to 2 a.m., you would, if you're calculating between 12 p.m., if you're calculating between, say, 11 p.m. and 10 p.m., it's an easy minus, right? But then if you're doing like 11 p.m. to 2 a.m., you might have to add. All this stuff becomes complicated. It'll do your head in. So just make a nice, simple number that can make your time sort correctly. It can make your calculations easier. The last tip, you really need to understand the business processes and the source system. So some systems log timesheets automatically as they happen, which is one that I worked on recently. So a timesheet's not somebody submits a timesheet at the end of the month. They go in and they start their shift, they log on, and the timesheet starts, and there's no end time until they click log off. So you have timesheets in progress, essentially. So you might have no end time. What sort of flags and filters are there? Is there like an approved flag? Do you need to report on only approved timesheets? Do you need to report on unapproved as well? What are the considerations there? What's the approval process? How do we need to deal with breaks? How are breaks recorded? All of this stuff you really need to spend the time workshopping and figure out before you dive in and start building the reporting.
And one thing I don't know if it's mentioned here, but if you go back to your previous slide that shows the facts and modeling. So something here that is a best practice that, and maybe I missed the specific comment of that, is splitting your date and time is always 100% recommended in Power BI. If you have a date time table, you're looking at millions of rows of, like, if you're all the way down to the second or millisecond, like it's many rows, but like splitting this to like 15-minute increments, you have hundreds of rows in your timetable. Your date table is your date table. You've eliminated hundreds of thousands, if not millions of rows. So like they're nearly universally, there is almost ever no reason to ever have those two together. Like the one caveat is like, oh, I want like a single slicer that does both. Like, yeah, sure. But like at what cost is that convenience versus you have a date slicer, you have a time slicer. Yes, you have to click twice instead of once, but like your model will thank you, and everything is going to be a lot more performant. So yeah, like I always like to just emphasize that anytime I see it, because it is just like in other universes outside of Microsoft, maybe not, but it is very highly recommended to do exactly what this is doing here. When you have a daytime column, yeah, you split it and then have two dimension tables, for one for each.
100%. It's something you see done wrong all the time too, right?
Yeah.
Cool. All right. 3 DAX calculations I want to look at now. So let me take some time to explain this properly. So for all the examples, we're going to use this sort of bracket in the diagram here. So we've got 1 p.m. and 2 p.m. And we're going to look at these calculations. So we want to count the number of staff on shift between 1 p.m. and 2 p.m. So in this case, that would be 4. We want to count the number of minutes between 1 p.m. and 2 p.m. So if we think of 15-minute increments here, this would be like 15 minutes from this one, 45 minutes from this one, an hour from this one, and 30 minutes from this one. And then we want to calculate the cost for it. So the tricky part that I wanted to keep in mind before is you got to remember that our model filters things by start date. So if we have that relationship and we don't deal with it in our DAX at all, when we try and count something at 1 p.m., it's not really going to show us anything because nothing started at 1 p.m., right? Nothing, well, you'll get these because they started within that filter context, but like it's not going to count this timesheet because that started at 12, right? It's not going to count this timesheet that started at 11:30 or whatever. So we need to deal with that. So we need to basically remove that filter in our DAX and then explicitly add the filters back in that we want to count in this specific window. So I'll show some DAX. I'm going to try and flick back and forward between this diagram because I think it's helpful to help understand the DAX. But a filter context of 1 p.m. here. Another thing to keep in mind, filter context of 1 p.m. in your report encompasses all the times between 1 and 1:59. And then 2 would be 2 to 2:59. That's how the filter context works, right? If you got a timetable at a minute level and your timesheets are, at, whatever times they have, if they fall within 1 to 1:59, it'll fit under this point of filter context. All right, let's have a look at some DAX. Let's bring this over for a minute. Maybe I'll flick to the other one in a sec. So the first DAX is quite simple. We're going to start simple and get a little bit more complicated as we go. But the first one is just counting the number of timesheets in that window that we looked at, 1 p.m. to 2 p.m. The first thing we need to do is find that minimum time, which is 1 p.m., right? That's what this variable here does. Is give me the point of filter context that we have. What are we reporting on? All right, we're at 1 p.m. We need that, and this number that I've used here, this late hour sort, that's just that number I talked about. It's that custom sorted number. So saying just give me the minute number in my custom sorted number where we're at in the chart, and then fairly simple. We're just counting timesheets, count rows of timesheets, but we would need to remove that filter on time because we don't want to filter everything by the start time. We need to say, so just give me all the timesheets for this date. We still got our filter on date, but we've removed all the time filters and said, just count me all the timesheets. And then we reintroduce our explicit filters to get the ones that we want in that place in the chart. So we say, give me all the timesheets that end after 1 p.m. because our minimum time is 1 p.m. Give me timesheets that end after 1 p.m. or where the end time is after 1 p.m. or blank, so they haven't finished because they could still be in progress. Like I said, this system, people log on, the timesheet clicks. So anything that's anything that's ended after 1 p.m. or has no end time, and anything that started on or before 1 p.m. Get confused with these filters. Yeah, either it started at 1 p.m. or it started before 1 p.m. or it finished and this comma is an and. So it started on or before 1 p.m. and finished after 1 p.m. or has no finish time is what this is. So most of these calculations are about that. We need to cover a bunch of use cases. So if you look at this, there's kind of 4 different use cases that happen here. You've got timesheets that start and finish within the window. You've got timesheets that start before the window and finish within the window. You've got timesheets that start in the window. You've got timesheets that start before and end after the window. There's kind of like 4 different conditions there that you need to count. And because of that model relationship, we end up needing to remove the filters and then add them back in. All right, we'll ramp it up a level and go up to minutes. Let's say we don't just want to count how many timesheets are active here, which is 4. We now want to count the amount of minutes in this window. Okay. We'll zoom this out slightly.
I always applause for dark mode too.
Thanks. Yeah. I wasn't a fan for a while. I was, it took me a little while to get used to it, but then now I've gone there with everything. I can't go back. All right. So the first thing is, in this example, we're doing like a complex iteration. So first thing you notice is there's a lot of variables. Because we're doing this and we want to be efficient, the first things we do is think about efficiency. We need to make good use of variables so we're not recalculating stuff. And we want to create a table that's the minimum amount of columns that we need, so that when we're iterating, it's only, we're not iterating a full fact table, we're just getting what we need. So first we create this table here. Well, first we grab the boundaries within our filter context point. So this min would be 1 p.m. This max would be 1:59. So we grab our boundaries, and then we create this table with just the columns that we need for our calculations. In this specific one, I actually don't need this column, but anyway, we grab our timesheets, our start time, our end times, our total times, and we make sure that it's at the right grain by timesheet. And then on that table, we remove all the filters on time, again, because we don't want that filter on the start time to be affecting the calculation. So essentially, we have our table to iterate that has everything we need, no extra stuff. Well, there's a couple extra things here, but that's because anyway. And then we remove all our filters on time. So we basically have a table of all the timesheets for that date with just the details that we need. And then we start the iteration of our table with SumX. And for each row, each timesheet in our table, each row, we grab the end time of the timesheet and the start time of the timesheet. So that's the first step. Minimal table, no filters on it, all timesheets for the date. Go through each row, record the start time and end time, and then we need to check these different conditions based on that diagram I was showing. So firstly, if the timesheet started after 1:59, we don't need that. So don't consider that. That's what this line says. If the timesheet was after 1:59, blank. We don't want anything. If the timesheet started before or equal to 1 p.m.,
okay,
don't consider that, blank. We don't want anything that started, if the timesheet ended, my bad. If the timesheet ended before or on 1 p.m., we don't want that. If the timesheet ended after 1:59 and it started before or equal to the start time of the filter context, then we can count the minutes, which is this timetable. I'll just change this. Sorry, I've adapted a few of these for this presentation, but because we remove the filters on time, we can count time. If the timesheet started after or equal to the minimum time and ended before the end of the filter context, then we can take the start number minus the end number. Timesheets that start and finish within that context, we just do a minus the numbers. We can calculate that. So this one here is basically, let's just have a quick look back here. This one here, the count rows of time, this filter is basically grabbing this one here. It's saying anything that started like way before and finished after falls outside of that point of context. Just count all of it, count all the minutes. This second one is the times that start and finish within that thing. So that's this one here. It's saying we'll take the start time and the end time and minus them from each other. This one is things that start within the filter context. So if it started after or equal to 1 p.m., then we just take the max time of the filter context, 1:59, and minus off when the timesheet start number. And then timesheets that finish within the time filter context. So I don't want to spend time talking through all of these different filters. The idea is basically there's these 4 different kind of use cases that you need to capture when you're calculating the minutes. And it's basically saying, well, we've removed all the filters on time because we can't filter by start time. We have all of our timesheets for the date in a nice, small, tidy table. We're iterating that and saying, does this timesheet fit what criteria? Yes, this timesheet starts before the minimum time here and it finishes after. So we'll just count all these minutes. This one starts here, so we'll count between here and here, between the start time and the maximum point of the filter context. This one started before, so we need to count it from 1, the minimum time in the filter context, to the timesheet end time. And this one we need to count from the timesheet time to the start time. So it's this complex kind of filtering between the minimum and maximum of your filter context, 1 and 1:59, and then the start time and the end time of your timesheets, and how you count these different conditions. It's essentially implementing all the filtering, because we can't leverage the model for it, because again, we've got our model at that grain that we decided, which is, timesheet, date, and employee. We don't have it at a time grain. We can't use time to filter. We have to implement the filtering ourselves.
And again, the data behind this, out of curiosity, again, remind me so for that measure that you're running against, what is the performance against the fact? Are we looking at a 350 million row table, or?
Good question. I should know. No, it's reasonably small. So the reports are performant. I'll show some later. They run fast, but no, I think it's. Can I have a quick look? I don't know. Look, I'll give you an estimate. It's probably like hundreds of thousands. Really, it's not.
Oh, that's not too bad.
No, and with that high variable use, where you just capture like the start and end of your filter context, and you capture like the start and end of each timesheet as you go through, it's quite fast, because you've got to keep in mind too, like a lot of the reporting use cases for this is looking at one day. So you're always like, when you're looking at the time, it's not so much that you're looking at like averages across weeks and months. You could do that. Most of the time you're looking at a day and saying, well, where do these timesheets fit within this day? So it's not that you're iterating the whole timesheet table. You're usually iterating like 1 day's worth of timesheets, which is usually a lot smaller, right? In most of the reporting use cases in this case, it would still be quite performant, I reckon, even if you wanted to look at like averages over a week or month or something.
Okay.
So yeah, this gives us, basically go through each row of this table we created. We implement our custom filtering to calculate all the minutes that are in that specific window, and then return it. And then this last bit is just, if you are at like a date level, you don't need to do this complex calculation. In this case, each, is this my minutes calc? Yeah, this is supposed to be something else. Anyway, this would be minutes here.
For that, yeah.
What this says is just saying, only do this complex calculation if we're at the time level. Otherwise, just do like a simple sum. So you could use is in scope here as well, I think. I can't remember exactly why I did this, but there was a reason. But, you use is filtered or is in scope or something to say, are we in the right place to execute this calculation? Are we looking at things on a time scale? If not, we'll just do a simple sum, because that's what this grain's good for in the model. Okay, so The next use case we'll look at is with some breaks. And in this example, we're going to include breaks in the calculation, but assume that on each timesheet, we just have a total break duration, not a start and an end time. Because let's say we don't have like a separate fact table for breaks that lists all the breaks associated with one timesheet. Let's say we just have the timesheets, and to make life easy for summing calculations and stuff, we've just put a break duration on every timesheet, not there was 3 breaks on this timesheet and these are all the start and end times. We just say, here's a timesheet that started this time, finished this time, there was 30 minutes worth of breaks on it. How do we deal with that?
Yeah, that's a good question.
So it's the same calculation. I won't talk through all of it. It's the same filters and everything. We're still getting the minutes out of this variable here, calculating all those minutes with all those filters and giving us the right amount of minutes within that filter context in the report. But then we have this total time on the timesheets, which is in that's timed by 60. Anyway, we have this total time on the timesheets. So we can use that to say this is the timesheet has all this time, total time for the timesheet. This is the minutes within our filter context point. And then we can divide our break duration by the total timesheet minutes to give us kind of like a it's like a total per minute break amount, basically, right? We divide the total minutes for the breaks by the total minutes of the timesheet, and that gives us how much break time there is per minute. And then we multiply it by the minutes on the timesheet. So it's like an allocation, right? Allocating the breaks out across every minute. You say, we have 30 minutes worth of breaks on this timesheet. That means, and say the timesheet has 2 hours on it, or say the timesheet has 10 hours on it to make it easier. That means we need to take 3 minutes off each hour kind of thing. It's like an allocation like that, but we're doing it at the minute level. We're saying for each minute, minus off this small amount to account for breaks. And then we just take our minutes and minus off the break minutes. And that can happen at any level of detail. And then again, we just do our check to see if we're at time level, and then we return our calculation.
Okay. How long did it take you to initially come up with the formula for this? I guess was this done in any in a pairing of it with Claude or other stuff, or just kind of off the cuff?
No, I mean I definitely use Claude for things that I'm not as much of an expert in, other coding languages and stuff. But DAX, I feel like I'm pretty solid on. So I just sat down and nutted it out. In saying that, it took a while because, and I've even simplified this version a little bit because there was other data issues and business rules and different things that I dealt with originally. But it took a little while because I tried some different approaches, and then finally I settled on this approach that was performant and seemed to do what I need to do. But I mean, the basic concept I think is pretty basic. There's a lot of code here and it seems a bit more complex, but I mean, essentially you're just saying, give me all the timesheets for the day, make me a nice small table to iterate, remove all the filters from it because I don't want to filter by start date because I want to count in a custom way because I have durations that started before or after or in, and then saying, these are the conditions of what you need to count, and then, finishing it by just doing a check and saying, do we need to execute this more complex formula or can we do a simple sum?
Yeah, I mean, I guess it's just for the end of the day, it's really just declaring variables, formatting it out, and
And I think that's why I mentioned some of those tips. Definitely this would be much more complex if you were trying to use times and minus and add times and times that go over different days and stuff. So some of those things, like just having a simple a number for your start times and end times and a number for your filter context, made the debugging and checking stuff a lot easier. And yeah, I mean, essentially it's implementing custom filtering. So you're saying define some variables with all the boundaries, the starts and ends of the shifts and the starts and ends of the filter context, and then go through each timesheet and say, where does it fit in what I want to count in this bit of filter context? All right, last one is cost, which is probably
yeah. Well, and
the most
that's where the
important.
money is, literally and metaphorically.
Yeah. And so like we have a cost on a timesheet, usually like a total cost for the timesheet. But again, we want to see, I'm just going to get rid of this, not necessary. We want to see not the total cost of the timesheet. We need to allocate it out again, right? Like we need to see between 1 p.m. and 1:59 p.m. what was the total cost of all of our timesheets? How do we do that? And that's really what those previous calculations were kind of working towards. Again, it's the same thing. We find the boundaries of our filter context. We prepare a nice small table with no filters on it from time. And then we start the iteration. We find the starts and ends of our timesheets. We check each timesheet to see if it's something that we want to count the minutes for. We count the minutes in different ways. We get our total timesheet minutes. We allocate our breaks out so that they are allocated across the entire timesheet, so that we get a correct total, but we also can have kind of like the breaks are kind of accounted for in any place on the time axis. And then we figure out a per minute cost. So again, we do that allocation with the cost for the timesheet. We get the total cost of the timesheet and we divide it by the total amount of minutes on the timesheet. So that gives us like a per minute cost for the timesheet. And then we just multiply our per minute cost for the timesheet by the amount of minutes that we've counted in that 1 p.m. to 1:59 p.m. So we're essentially saying between 1:51 p.m. and 1:59 p.m., say we have like 2 hours and 45 minutes of timesheet minutes. Our per minute cost for each timesheet, or for each, I'm bad at explaining this sometimes. Let me start again. So for each timesheet, let's say for one timesheet, and I'll bring back the thing. Let me say this again. So for one timesheet, let's take this one, for example. For this timesheet, we have 30 minutes worth of time. What is the cost of that timesheet? Well, we find that timesheet in one of these conditions, which is this one. It starts and finishes within the filter context. So we got those minutes for that timesheet. We remove any breaks, and then we say for that 30 minutes, for the whole timesheet, we have a per minute cost of say $1.50. And then for that timesheet, take that 30 minutes and times it by our per minute cost of $1.50, which means the total result is 45. But we do that for every timesheet in our iteration, and then we sum it all up at the end. And then again, we check, are we on our usual reporting time fields? Yes, do this, because we're looking at a single day of time axis. Let's do our calculation and get our cost for each individual time bracket. Otherwise, we can just sum up our cost. Every timesheet has a cost, so we can just sum it up. And so this would work. Obviously, this calculation works at 15 minutes, an hour, 2 hours, any kind of time increment, because it's just going through and saying, what's the current boundaries of filter context that we're reporting on? And then what are the timesheets that we need to count between these twos? Looking at the start and end times and calculating our minutes, figuring out some per minute costs and per minute amounts for breaks and costs, and then multiplying it out by the amount of minutes that we've counted in that bit of filter context. So look, I mean, I don't normally write DAX this complicated, but I was coming on a live stream, so I better come up with some kind of good example of something a bit more above the usual sums and averages and things. So I think this is, this is kind of tricky when it comes to DAX, when you need to count things that, thanks for that comment. I don't like complicated DAX either.
And when you have to deal with like Yeah, especially like shifts and other stuff like this. There's a lot of like else if this, but not this, and
Yes.
except this. Yeah,
I mean, the crux of why it's complex is that we're at a date grain and we're trying to report at a time grain. And we don't have, like, this is where that other level of detail would simplify things, right? If we have everything by time and the snapshot of every minute, then this stuff's kind of a lot simpler, right? Because you can just say, like, count the, it's basic filtering and stuff if you have it defined at that minute level, because your filter context works. At 101, you have a snapshot of what everything is. In this case, we don't have a snapshot at 101 of what everything is. So, our level of detail is date. So we need to figure out durations, look at start times and end times, and implement this filtering. But it is performant. I'll show you some reports next. I think that's all my slides. I think there's a couple of business use cases, just some quick business value propositions. So some of the things that you can look at, I'm sure there's many, many more, and this is just a couple based on kind of some
sure.
shift-based data that I've been working on. So, cross-referencing rosters or schedules against historical performance for better planning. So you need to build your roster or schedule. There's obviously a lot of insight that you can provide around that to say, here's what the roster should look like. Here's a roster forecast. Looking at your revenue forecast and your roster acting as like a wage cost forecast, and looking at wage percentages so that you can say, yes, we're on track. Our wage percentage is acceptable with our plan, or no, we're not. Our wage percentage is not acceptable based on our current plan. I've done some real-time stuff with this kind of thing too, where I've had like dashboards displayed on the floor to give sort of managers real-time insights where they can say, you know what, this is our revenue forecast, or it could be anything, our output forecast on a machinery floor or whatever. This is our forecast. This is how things are currently tracking. This is how many people I've got on. This is how it compares to previous days. Should I knock somebody off? Should I finish someone now? Should I get on the phone and start calling people and try and get more people in? Obviously reviewing history, so looking at your wage percentage and staffing numbers to look at core issues, like looking back and saying, well, all of a sudden our wage percentage was super high here. Why was that? Oh, it's because we had way too many people on, or we earned a lot less than we thought, that kind of stuff. Another one that I'll show you an example for is auditing timesheets before payroll. It's a really good one. So payroll's hard to reverse in a business. It's hard to pay everyone and then say, oh, we made a mistake. Can we take the money out of your bank account? Can we wait till next month to adjust it? It's painful. So making sure that all your timesheets are correct before they go to payroll is important. Now, you can also, in some of those cases, if there is some kind of time theft happening in a business, people are being dishonest on their timesheets, it could help with that if it's not sort of automated. And then, just ensuring compliance around how timesheets are entered and with that kind of auditing process. So we'll look at a couple reports. So these are real reports, but what I've done is I've used some trusty calculation groups to randomize all the numbers. And so these numbers make no sense. They're complete nonsense. The client was nice enough to say, yeah, you can show some of the reports that you built, but we don't want any of our numbers shown. So this is I've used RAND in a calculation group, and I've also used a multiplier. So they have no kind of correlation to the real numbers. They're multiplied by a multiplier and then randomized. And you can see if I refresh, they'll change. So they're totally randomized. So this is just a quick overview of like a wage percentage versus revenue trend, looking at how your wage percentage was over time. Was it in the green? Was it in the red? That kind of thing. And you couldn't do this without doing some of those calculations like I showed. If you just have timesheets with a start date and end date, to do this, you need to have revenue by time, and you need to have wage costs by time. Looking at your timesheet cost versus revenue, how the trends correlated. And you can change axes, look at it by 30 minutes or 60 minutes. Now, these are these reports, but it's a little slow because I've got this calculation group operating over every measure, so it slows it down a little bit. This is a similar report that just looks at some gross
Nice
profit.
use of the ribbon charts, of course.
Yeah, I love a good ribbon chart. So the first one's looking at just, what was our gross profit based on the revenue and the wages. And then this one's looking at, your cost of goods, your wage cost, and your gross profit, how that adds up to your total amount. And then over time, which was the highest thing, was our cost of goods and wages higher than our revenue, which you can see here. See, like the wage cost was our top amount. It was more than our COGS and revenue. And, this is obviously a bad hour right here.
Yeah, not a good one.
I can't look at that one. So look, and the last report, I think we're pretty good on time, right? We're just about over. So one more report I'll show, a kind of a cool use case. This is a translytical workflow. Again, I'll just reset this so that we can see it. So this, I've just masked all the employees' names, and then I've put this random measure here. So I've used a calculation group again to just blank out all the employee names, and then you can see this change as the visual refresh is just a random number. So again, doesn't make sense, but the idea is this is all the timesheets, and you can filter them in different ways. And then you can say, well, just show me ones that have issues based on certain rules. You can drill down further and say, like, show me the long shifts. And then you can click on a row, and you can enter a comment, like I'll just put comment remove, but you could enter, this is for managers to come through and approve timesheets. They come through, they select a timesheet, or they can actually select like 5 timesheets, select multiple comments, and then submit. And it will take a little bit, but it will come back and update a comment. So it's like, and it all writes, you've got a paper trail as well. It's writing to like a SQL DB, so you can go back and say, what happened with this timesheet? Oh, so-and-so actually approved it. I don't know why it's taking so long, probably because it's a live stream, but anyway.
Yeah, there's a lot of just that team sucks. we can agree on that.
Yeah. And it'll take a little while. So gone a bit of a different route with this one. I used a SQL DB to store the comments for write from the UDF, but then I wanted to use a direct lake model to populate the report so that I didn't have to refresh. And rather than use like an import model with direct query, I decided to use like direct lake. And so I just shortcutted the comments from the SQL DB into the lakehouse and then built a direct lake model. You can see there it's updated with the comment. So that's I guess an example of using the data to, well, not specifically that DAX that we showed, but another kind of use case for some of the newer features in Fabric, I guess, and timesheet reporting, like auditing timesheets and timesheet approvals with translytical apps. That's pretty much it for my content, Reid. I hope people found something in there that was useful, or some good tips and different ways to think about things.
Let me get this back up to here for us. No, I mean, I always like to see in the ways that people usually end up trying to report off of this too, for some of that. So it's a good case study. I think to both walk through the back end, the scaling complexity that you can get to very easily creeping up on a lot of rows if you're not careful. But then also considerations of designing the data, because it's, yeah, when you have these artificial constructs of time, it takes a lot of consideration into not only how to visualize that, but also how to map it from a modeling perspective.
Yeah, and I guess, a key use case for this project that I worked on was cost control for wages down to like a 15-minute level was the overall the overarching requirement was improve efficiency in operations, but a big part of it was down to a 15-minute level. How can we see if our wages are blowing up or not?
And I had a couple of comments just to bring up on this. Rohan mentioned that a great session as usual by Kane, very informative. Also that there's for just as an FYI, I guess there's a custom visual called Calendar by Talon, which is really great for displaying missing timesheets at a day. That'd actually be nice.
Good comment. I know Rowan. I've worked with Rowan before. He's an excellent Power BI consultant. So I'm sure if he said that it's good, it would be amazing.
It is. Let me quickly. So this is Calendar by. I'm just saying if I could drop a link. There it is. I'll at least put a link in there for people if they're curious in the chat here, because I usually the only one who can do links. So there's the app source version of that. And then Donald had a comment. Let me also get that on the screen. The first real Translytical report he's seen that you were showing. So sure is some appreciation in there. A little bit of love for that. So
thanks, Donald. I mean, probably like most people, it's so much fun, right? Translytical reports, how much hoops we needed to jump through for like write back and stuff before. Like when this use case came up, I was like, yes, I can build something with a Translytical report. One thing I found that's tricky with them is just getting the results. Like from a user perspective, the time, if a user's used to using a spreadsheet to record some of this stuff and they just put comments in or something, the time taken for the UDF to execute and then get it back into the report, whether you're using like direct lake like I used here or direct query in an import model or something, that's the only thing. I was trying to figure out how to make it different, faster, because what I found too is like shortcuts. I shortcutted the SQL DB into the lakehouse and then brought it back into the report. But the shortcut's not instantaneous. There's like some lag in the sync there sometimes with a shortcut. And even if you refresh the SQL endpoint, it doesn't always mean that the shortcuts pulled the data across. I originally had like a SQL endpoint refresh in the UDF. I ended up removing it because I wanted to make the submit process faster. So I hope they kind of figure some of those things out with performance a bit more. Performance of the UDFs, and hopefully it gets optimized a bit.
And I guess follow-up question to you as well on, as we're wrapping up, for resources and links to ensure that people have some things to go look at. Besides anything that's already in the description, is there any other references for things on the topic of what you presented, links to anything that you've shown, or anything else outside of your blog that people can check out?
No, not really. I mean, the only thing I know that's similar to this is that SQL BI DAX pattern on events with duration, and obviously, anything that SQL BI has on that topic is probably the go-to.
Yep.
And then, I mean, the Translytical apps, it's Microsoft Docs, really. I can't think of anything, Reed. Sorry.
Yeah,
I don't have much on my blog. Maybe I should put something up there. And I can't share any PBIXs, unfortunately, because this is some actual real-world use cases. So
I'll drop the link to Translytical tasks. There you go. Yeah, perfect. Well, then I think with that, we can use this to do a soft wrap-up. But as always, I appreciate you for coming on to this. Hopefully get some good viewership on the video as well. You can add it to your catalog of the MVP contributions.
Yeah, awesome. All right. Thanks so much, Reed, for having me on again. It was great fun.
Absolutely. Yeah. Thank you for sharing this. Everyone have a great weekend. And Kane, I'll look forward to getting you back on again sometime in the future as well.
Awesome. Yeah, look forward to it.
Excellent. And have a great Saturday and take care.
You too. Thanks, Reed.
All right. Cheers.
Thank you so much for watching. Please consider hitting that like and subscribe button. And if you want to help support this channel, take a look at our channel memberships or our merchandise store for cool swag. And last but not least, please consider sharing this video on your social media platform of choice to help our channel grow. So, until next time.